Before we tell you how to manage our controller, we consider it necessary to remind you about the basics of lighting marine aquariums. Marine life in the wild receives natural sunlight, the spectrum of which looks as follows. On the x-axis we can see the wavelength of sunlight. That part of the spectrum visible to the human eye is shown in the same color that we can see the light at this wavelength. The ultraviolet and infrared parts of the spectrum are invisible to the naked eye, so they are shown in black. The y-axis shows the radiation intensity. As you can see, the light spectrum of the sun is full, meaning that there are no empty spaces across the entire range of visible light. Therefore, we must also strive to reach the maximum full light spectrum in order to achieve the possibility of seeing all the colors of our aquarium. Unfortunately, many of our usual light sources do not have the full spectrum, which leads to the distortion of visible colors. Let's look at this simple example. Here we have illuminated both a green and a red apple with the full spectrum white light. As you can see, the colors appear to be represented correctly. However, human vision is such that when we see light consisting of only two parts of the spectrum, blue and yellow, it appears to be a white light. Let's take a look at how these apples appear under this light. The apples appear terrible because this pseudo-white light lacks the necessary elements of the spectrum to show the correct red and green colors. Thus, in order to see all the variety of colors in an aquarium, we need a full spectrum lamp. Then also, because color perception is unique for each person, standard colors do not exist because the appearance of color is formed in our individual brains and other factors may affect this. This means that our color perception may be somewhat off at times, even in simple cases. Squares in the middle of the cube. Obviously they're different colors, right? Let's take a closer look. In fact, as you can see, they are the same color. Therefore, fine-tuning the spectrum of the luminaire is very important, as it allows you to show the beauty of your unique aquarium, especially tailored for your unique color perception. Due to the depths of their habitation, coral has different responses to the light spectrum. Point being that seawater works as a light filter. Here you can see how the solar spectrum looks at different depths. This graph shows the visible spectrum for a depth of 5, 10, and 15 meters. The greater the depth, the darker colored the graph. As you can see, the red light does not permeate a depth of 15 meters. At the same time, the shortwave light permeates into the water very well. This is the reason that good lighting for marine aquariums has approximately this spectrum. The shortwave part of the spectrum is often called actinic. A large amount of actinic light provides a very aesthetically pleasing fluorescent effect to coral, which is naturally very popular with aquarium owners. Furthermore, the actinic spectrum is very well utilized by coral. If the actinic portion of the spectrum is greater than the amount of light necessary for photosynthesis, a lot of coral do not need further parts of the light spectrum. Therefore, for good growth and coral fluorescence, it is important to have plenty of actinic in the lamp spectrum. When you configure a spectrum of lighting, it is necessary to consider the most important feature of human vision. The human eye perceives the same amount of radiation with different wavelengths as lights of a different brightness. This graph shows how brightness of light appears to the naked eye depending on its wavelength. As you can see, the yellow-green light with a wavelength of 555 nanometers is about 3 times brighter than red light with a wavelength of 630 nanometers. At the same time, violet light with wavelength 410 nm looks significantly dimmer than red light, about 30 times dimmer in fact, and is therefore about 100 times dimmer than the yellow-green light. This shows that the addition of even small amounts of radiation from the red part of the spectrum significantly affect the visible color light lamp, and the addition of blue-violet light affects it only slightly. Remember, this is what the spectrum of a good aquarium lamp looks like. Despite the low visibility of shortwave radiation to the naked eye, it brings much more energy than the radiation of the other parts of the spectrum. Therefore, lamps with a high prevalence of the shortwave part of the spectrum do not look so bright to the human eye, but actually are very bright for coral. This is why we don't need to check the brightness visible to us, but rather the amount of the lamp's radiation in order to know how much light is received by our coral. Our lamps fully implement all these requirements. They are full spectrum, they have the possibility of fine-tuning the spectrum, they have a sufficient amount of the actinic spectrum, and the managing of the lamp implemented to avoid mistakes during adjustment of the amount of radiation. Now let's see how you can control the spectrum of your lamp with the help of our advanced controller TrueSpectrum. We named it that way because it is the first in the world of its type to utilize a unique control interface, which allows you to control exactly the spectrum of luminaire instead of the individual channels of LEDs. This method of control not only allows the easy manipulation of any spectrum, but also ensures the user from making mistakes caused by the incorrect use of the lamp. Let us consider the management interface of the controller TrueSpectrum on example of our flagship spotlight Sirius 180. The control screen is divided into two parts, upper and lower. The upper part is responsible for the real-time control mode. The lower part shows the daily cycle of illumination. Let's get acquainted with the real-time control mode, that is, with the upper part of the screen. On the left-hand side, you can see the radiation spectrum of the lamp at this point of time. Here, on the horizontal axis, the wavelengths of the visible spectrum from 400 to 700 nm are shown. The vertical axis shows the power of radiation from the lamp now, in percentage of maximum power, which is obtained when all LEDs are at full power. Above the picture of the spectrum, we see the amount of radiation of the lamp at this time in percentage of the maximum possible. This is a very important indicator. Later we will talk about it in detail. The graph of the spectrum colored in exactly those colors, such as the human eye can see, of the radiation with this wavelength. On the right side, there is a set of sliders to control the individual channels of LEDs. The sliders are colored approximately in the colors of the radiation spectrum, which is given by the LEDs in this control channel. Spectrum of all types of LEDs are digitized and included in the control program. The program also includes data on the amount of all the LEDs radiation of the spotlight. Let's take a look at which LEDs respond to any slider and how their spectrum appears. Let us consider sliders, starting from the second from left to right. The second slider is responsible for LEDs radiating the white light. These LEDs have a very wide spectrum, wherein the radiation almost of all parts of the spectrum is presented except for the blue and violet. The third slider is responsible for the LEDs radiating the violet light. They provide the critically important radiation for coloring, fluorescence, and coral growth. Three types of LEDs are represented in this channel, reminiscent of a trident. Notice how dim to the eye the radiation of these LEDs seems. The fourth slider is responsible for the LEDs radiating the royal blue light. They also give off radiation necessary for healthy coral. As you can see, it has quite a narrow spectrum. This light also looks quite dim to the eye. The fifth slider is responsible for the LEDs radiating the blue light. They are necessary to compensate for the failure of the blue part of the spectrum of white LEDs and to underscore the blue tones of color in the aquarium. The sixth slider is responsible for the LEDs radiating the turquoise light. They help to emphasize a beautiful turquoise color tone. The seventh slider is responsible for the wide spectral LEDs radiating a yellowish green or lime light. They are extremely bright and therefore are intended to increase the apparent brightness of the lamp. Notice that a wide spectrum area is covered by the radiation of these LEDs. The eighth slider is responsible for the wide spectral LEDs radiating orange light. They are very bright and emphasize the warm colors in the coloring. The ninth slider is responsible for a wide spectral LEDs radiating red light. They emit the red tones in coloring. The 10th slider is responsible for the LEDs radiating a dark red ruby light. They emphasize the rich red color. Please note that a graph of the radiation from these LEDs has the form of a thin needle. Installing sliders of parts of the spectrum, we can get almost any spectrum of lamp. For example, this is how the spectrum of the sun on the Earth's surface looks on a cloudless afternoon. This is how the spectrum of sun at dawn appears. This is like the spectrum of sun when it is covered by clouds. Thus, we can easily see that the 9-control channel perfectly solves the problem of the formation of almost any spectrum. Also, you can very accurately set the position of any of the sliders. To do this, click on the digit below the slider, and you can indicate the height value of the slider to the precision of 1/100%. As we have seen, by setting the slider channels in a certain position, we can get almost any of the visible spectrum. Let's set the sliders like that. Now, with the first slider, we can increase or decrease the amount of radiation without changing the spectrum itself. Watch as we move the first slider up and all the other sliders proportionally increase their height. Move the slider down and all the other sliders proportionally reduce their height. That is the function of the first slider, to change the amount of the radiation of the spectrum without changing the spectrum itself. We will call it the slider of radiation intensity. Please note that because the different variants of spectrums contain different amounts of radiation constituent parts, the maximum radiation of a spectrum may be different. For example, let's put all the sliders to the highest position. It is motor switch of all LEDs at full brightness. Of course, the amount of radiation in this case will have the maximum amount of 100%. Now set the spectrum similar to the settings for the sun on a cloudless afternoon. As you can see, the maximum amount of radiation for this spectrum is 56%. Most importantly, we must not forget the fact that the human eye and coral perceive and react to light in different ways. To find out exactly how much radiation the lamp is now giving, look at the number of total radiation power, which shows how much percentage of the maximum amount of radiation the lamp is producing now. Let's set all the channels to the minimum and then add as much as possible to the purple and blue channels. As you can see, these two channels produce more than half of the lamp radiation, despite the fact that our eyes see the light as being very dim. This shows that while the spectrum is dimly lit to our eyes, it is very bright for coral. Now let's set only the lime channel LEDs to the maximum. This light looks very bright to us, however the amount of radiation giving out is very small, only 7%. It means that the spectrum is very bright for our eyes, but dim for coral. Unfortunately, until now, there was no inexpensive way to know exactly how much radiation given off by the LED lamps for marine aquariums with certain settings of channels. The point is that the low-cost PAR meter apogee, which is widespread, has an error of up to 3 times in the measurement of the amount of mission critical for coral's shortwave radiation. Then there is also PAR meter LICOR, which is more accurate, but they are very expensive, about $1,000 US. Therefore, marine aquarium hobbyists have had to manage with LED lights almost randomly. TrueSpectrum is the first controller which solves this problem. Now, for the first time, you can easily and accurately calculate the necessary illumination for different corals. In the description of each spotlight is specified the area serviced by them in the case of lighting coral with average needs, in light intensity, and when all the LEDs are working at full capacity. Because you know the real service area, you can determine the correct amount of radiation for your coral. Spotlight Sirius 180 serves an area with a diameter up to 35 inches or 90 centimeters. Let's say that you use it for the area with a diameter of 23.6 inches or 60 centimeters. This constitutes 44% of its maximum service areas. Therefore, you must not exceed the amount of radiation 44% if in your aquarium contains coral with average needs in the light. If your aquarium contains more light-demanding corals, you can increase the amount of radiation by more than 44%. Thus, it is necessary to consider that even the most light-demanding coral should not be illuminated by more than 1.5 times, that is, not more than 66%. Write these numbers down, they will come in handy later. If you do not know how strong light your corals have received before, At first, do not use more than 2/3 of light on the amount that is obtained according to this calculation. Adjust to the preferred light intensity smoothly, up to 3 to 5% per week. Also, we recommend using the spectrums that will make the transition period to the new powerful light comfortable for coral. Please read carefully the description of the spectra. In any case, whether you have very light demanding coral or not, do not forget that the spotlight is a point light source, so that the maximum illumination will be directly beneath it, and at the edges of the area served by it will be much less. Therefore, the most light demanding corals should be placed directly under the spotlight, and soft corals, mushrooms, and non-photosynthetic corals on the periphery of the light spot. After you have finished the formation of the spectrum, you can save it in the gallery of the spectra by clicking Save As. To do this, select which part of the daylight hours relates to this range, select its name, and give it a brief description. If you are not sure which part of the daylight hours can be attributed to this spectrum, add it to the section Exotic. You can load a saved spectrum from Gallery Spectra. To do this, press the spectrum. You can see bookmarks of spectrum's galleries, sorted by time of the daylight. At each tile spectrum view thereof, and several icons. The top icon opens the description of the spectrum. At the very top, the description displays the maximum amount of radiation that this spectrum can give. Below, you can see its description. The next icon allows you to upload the spectrum to the control computer so that you can share it with marine aquarium hobbyists all over the world. Also, you can load spectra from a computer to your controller using the icon located at the top of this window. After clicking on any of these icons, a standard dialog window of File Manager opens. Let us return to the icons in the tile of the spectrum. Clicking on the icon below will remove this spectrum. The icon in the upper left corner in the shape of a star allows you to mark this spectrum as a favorite. In this case, it will be displayed in the gallery of spectra favorites. To remove the spectrum from the gallery, simply re-click on the star. After clicking on the tile of the spectrum, it will open immediately in the control screen where you can edit it as you wish and then save it under a new name. Now consider the below part of the screen controls. On the left side, we see the operating mode of the controller. When daily cycle is written here, it means that the controller is operating in accordance with the daily cycle of illumination. When we manage the spectrum manually, we move to the real-time control mode, appears inscription in real mode. If we do not change anything for a minute, after that the controller automatically switches to daily cycle. We can change the current time in the controller by clicking on it and typing a new value. Below we see a graph of the daily cycle of illumination. Each point on this graph is a new spectrum. The height of the point indicates the amount of radiation in percentage of the maximum possible. Thus, we clearly see how much radiation is received by our coral. Now let's see how we can generate the daily cycle of illumination. To do this, click on Edit. This will switch to the edit mode of the daily cycle of illumination. By moving the timeline by the daily cycle, we can see how the spectrum changes from one point to another. Please note, all transitional spectra are shown above the graph of the spectrum exactly in this way. If we click on a point, we choose spectrum associated with this point, and its name will look like this. We can change the intensity of the radiation of the spectrum without changing itself. For this, it is necessary to change the height of the slider of the radiation intensity. As you can see, the height of a point on the daily schedule changes from the minimum to the maximum possible for the spectrum. Moving from point to point, we can change the amount of radiation for each spectrum. If we want to use the new spectrum, we must first put a timeline to the necessary time, then click on the button Add Point and open the spectra's gallery. If we need to specify the time for this point, we can make it either with a second precision, entering the value. Then we click on the selected spectrum, after which it is set in the daily cycle. Please keep in mind that the daily cycle of illumination can have no more than 80 points. If we need to remove any point, just click on it and choose Delete. This control interface allows us to always know exactly not only the spectrum of the lamp at any time, but more importantly to know exactly the amount of radiation that it gives. Let's make two test spectrums, one of them with a rather large amount of radiation, which will consist only of the light of the violet LEDs. As you can see, it produces up to 27% of the radiation, although it doesn't appear very bright. The second spectrum will consist only of radiation of the lime LED. It can give only a little more than 7% of the radiation, although to our eyes it is very bright. Insert in the daily cycle of illumination the violet spectrum and the spectrum of lime. As you can see, the point of the spectrum of lime is located much lower than the point with the violet spectrum. You can also trace the change in the spectrum during the transition from violet to lime by moving the timeline by this segment. In the lower right corner, you can see the software version number and the cogwheel icon, which will be useful for updating the controller software. We will talk about this later when the first update will be available. At the end of this review, I would like to give some advice about the formation of the daily cycle of illumination. In coral's natural habitat, sunrises and sunsets are quite short, lasting only about an hour, but sunrises and sunsets in your aquarium can be longer if the amount of radiation is less than about a quarter of that necessary for your coral. For the case of using the spotlight, this quarter is composed from 11 to 17% of the radiation power of the lamp, depending on your coral type. Of course, you can also set the high intensity radiation for sunrises and sunsets, but if it exceeds the indicated values, you should add this time to the duration of daylight. Very long daylight may be difficult for the coral to absorb and may encourage lower algae growth, which is undesirable in a marine aquarium. Therefore, we do not recommend exceeding the duration of daylight by more than 11 hours, and the total duration of daylight, including sunrises and sunsets, even with a small amount of radiation, should not be more than 14 hours. We hope that our control interface will be convenient for you. Also, we are confident that with such a powerful tool for controlling the spectrum of your lamp, you can best enhance the beauty of your coral and foster their growth. We wish health to you and to your pets.